Hi, I'm Sean Gannon, and this is Minute Math. And today we're learning about real-world ratios and proportions. In this video, we're going to have a problem on ratio and total constraint, scaling with proportions, budgeting for supplies, garden space allocation, and travel rate calculation. So, when you're ready, let's get started. The ratio of two numbers is 5 to 7. Their sum is 72. What are the numbers? Okay. Well, this ratio of 5 to 7, well, that ratio would be the same thing if we multiply by a constant number to both sides. And we can let that be x here, the same number, right, to both sides. So it's a variable here. And so it's both going to be, well, x, the same constant number, whatever it is, has to be the same to both sides. We can represent this as x, and it'll still hold the same ratio. Now, they tell us here that the sum is 72. So we can say 5x, the first number, some number times 5 basically, plus 7x has to equal a 72. And now we can solve for x. 5x plus 7x is a 12x. It's equal to 72. Divide both sides by a 12. And x equals 72 divided by 12, which is a 6. Now we're going to take this x and multiply it by 5 and 7 to get our two numbers. So 5 times a 6, the first one, 5x, that's going to be a 30. And 7 times a 6 is a 42. And so our two numbers here are 30 and 42. A map scale is 1 inch to 50 miles. What is the map distance for 300 miles? So 1 inch on the map over 50 miles. That's our ratio here. Well, that's going to be equal to, and we can set it equal to this in the same ratio. The distance here in real life is going to be that 300 miles equal to x inches on the map. Okay, so we have a proportional equation here. We can solve for x. So to get x by itself, I'm going to first multiply both sides by 300. And so what we have here on the right is x is by itself. 300 times a 1 is 300, so we have 300 here. And if we want to keep our units, I can show you how it cancels out here. Right? This cancels here. The miles cancel as well, and we're left with inch. So 300 over 50 inch. And that's going to equal x inch, if you want to see that. Well, 300 divided by 50 is 6. So we have 6 inches is equal to x inches. And so 6 inches is what 300 miles in the real world would be on a map. So the map's distance is 6 inches. You have $50. Each item costs $4.25. Write and solve an equation for the number of items you can buy. Okay, so if x represents each item, the number of items we're going to be purchasing, and each one costs $4.25, we can multiply that out for 0.25 and set that equal to 50 to see how many items we can purchase at a cost of $4.25 that equals 50. So to do that, I'm going to divide both sides by 425. X is by itself here, and this is actually an approximate answer. 50 divided by 4.25 is 11.76. So how do we interpret this? Well, can we have a part of an item? No. And so we have to actually round down in this situation here, and we can purchase 11 items. So we can only have enough money for 11 items here because we had to round down because we can't get 0.76 of an item. So the number of items we can buy is 11. A garden should have vegetables and flowers in a 4-to-1 ratio. There is space for 30 total plants. How many of each type? Okay, so it's a ratio of 4-to-1. So if there's 4 parts vegetables and 1 part, these are parts here, 1 part flour, that we have a total of the combination of them 5 parts. Okay, so there's 5 parts here. Now there's a space for 30 total plants, okay? So what we want to do here is, well, see how many parts we can break up, how many of the groupings of 4 to 1. So we're going to take that 30 and divide it by 5 parts, 5 groupings of that 4 to 1 ratio, and that comes out to be 6 groups. Okay, so 6 groups that we can create. So now what we want to do is multiply the 6 by the 4 and the 6 by the 1. So the number of vegetables would be that ratio of 4 times the number of groups 6, which gives us 24. So we have 24 vegetables, and we have flowers. There's only one part, flower, but there's 6 groups of that, and 1 times 6 is 6. So we can have 6 vegetables, or 24 vegetables, and 6 flowers. Okay, I misspoke there. So we have 24 vegetables and 6 flowers. A car travels 450 miles in 7.5 hours. What is its average speed? All right, let's let S here equal the speed. Speed of the car, or the average speed. And so we know that this speed, if they travel for 7.5 hours, we multiply that by 7.5 hours, we should get 450 miles. That's how far we travel, 450 miles. Well, we want to solve for S. So I'm going to divide both sides by 7.5 hours. And so our speed S is equal to 450 divided by 7.5 is a 60 miles per 1 hour. All right, it's a unit rate right here, 60 miles per 1 hour, or we can just write this as 60 miles per hour, per 1 hour. And so the average speed of the car is 60 miles per hour. Let's now review what we covered in this video. We first had a problem on ratio and total constraints. Then we had a problem on scaling proportions, then budgeting for supplies, then gardening space allocation, and lastly, a travel rate calculation. I now leave you with a bonus problem. A company's revenue and expenses are in a 3:2 ratio. If the expenses are $60,000, what is the revenue? Best of luck. I hope you learned something here on real-world ratios and proportions. And as always, thanks for watching.